Section 5.1 exercises. Problem 1. Is it true or false that when an angle is in standard position, its initial side is along the positive y-axis? That is false. We start with the x and y coordinate system and always put the initial ray and the terminal ray along the positive x-axis, and then we rotate through our angle, and that would give you the terminal side here. And the initial side is always along the positive x-axis. So the statement is false. Problem 2. If the terminal side of an angle in standard position lies on the x or the y-axis, what is the name of that angle? And that angle is called a quadrantal angle. An example of that would be a 90-degree angle where you start on the positive x-axis and rotate through an angle of 90 degrees with the terminal side on the y-axis, or it could be where you start on the positive x-axis and rotate 3/4 turn and the terminal side is along the y-axis. Those are two such examples of a quadrantal angle. Problem 3. Fill in the blank so the statement makes a truth. An angle that is formed by half a complete rotation has what degree measure? Half a complete rotation, again starting on the positive x-axis, half rotation moving halfway along and ending with the terminal side on the positive x-axis is a 180-degree angle. So that's 180 degrees there. And because that angle is flat, or we say it is straight. So it's called a straight angle, which is 180 degrees, half rotation. Problem 4. A central angle theta in a circle of radius 12 intersects an arc of length 42 feet. What is the radian measure of that central angle? The arc length S is equal to the radius of the circle R times the central angle theta. So here we're given that R is equal to 12 and the arc length S is 42. So we substitute these values in. 42 is equal to 12 times theta, or 42 divided by 12 is equal to theta. And doing the division there, we'll have theta is 3.5, and this formula works in radians. So our central angle measures 3.5 rads, or radians. Let's go on to problem number 5. This is a conversion problem of 60 degrees to radians. So to do this, we will take the given angle 60 degrees and we will multiply by the equivalency. One equivalency that we tend to use is pi, which is a 180-degree rotation. So pi divided by 180 degrees is really a factor of 1, but that will convert degrees into radians. So we'll have 60 pi divided by 180, or if we reduce carefully, 6 pi over 18. Reducing further, we'll have pi over 3, or a third pi. So pi over 3 is a 60-degree angle. Now we wish to convert negative 300 degrees to radians. We use the same technique as above, starting with the given degree measure and multiplying by pi over 180 degrees. Of course, our degrees will divide out, and then we can divide out a 0, giving us negative 30 pi over 18, which we can further reduce. Dividing the top and bottom by 6 will give us a negative 5 pi over 3. So negative 5 pi over 3 in radian measure is the same as negative 300-degree rotation. Problem 7. Convert 6 radians to degrees. Okay, so start with the given measurement, 6 radians, and multiply by the equivalency factor. Here, since we start with radians, we want the degrees on top and we want the radian measure down below, so that the radian measure cancels, and 6 times 180 degrees will give us 1,080 degrees. Problem number 8. Draw the angle alpha equals 3 pi over 4 in standard position. So starting on the positive x-axis with initial and terminal ray, like so, we then rotate. One way to view this is 3 pi over 4 is 3/4 pi, and 3/4 is 0.75 pi, or in other words, it's 75% of pi. Pi represents a half rotation. So 1/4 would be right here at 45 degrees, and 2/4 would be here at 90 degrees, so 3/4 would take you here. That angle right there is 3 pi divided by 4. So it's a rotation of 1/4, 2/4, 3/4 of pi. Problem number 9. Find a positive angle less than 360 degrees that is coterminal with a 400-degree angle. Coterminal means sharing the same terminus. So we start in the same position and we end in the same position, except differ by perhaps a full rotation. So let's first draw the given angle of 400 degrees. So again, start on the positive x-axis. This would represent 360, and then we have to go an additional amount right here, and that is the large angle of 400 degrees. To get to coterminal angle, notice that we've already gone around the circle one full rotation, so we'll subtract that full rotation out, leaving us with 40 degrees left over, and that is the coterminal angle. So starting on the positive x-axis in the same way we did with our larger angle, but only rotating a small amount by 40 degrees with our terminal ray there is the coterminal angle. Problem 10. Find a positive angle less than 2 pi, so within one rotation, that shares the same ending point, is coterminal with a negative pi over 15 degree angle. So first, let's draw the negative pi over 15 degree angle. Okay, so starting positive x-axis here, and the rotation will be in the clockwise direction. Negative angles are measured this way. A very small amount, this way, negative pi over 15. So there's our given angle. Our positive coterminal angle will be moving in the positive direction and ending in the same spot. So moving around the circle in the counterclockwise direction and ending at the same spot will be the coterminal angle. So one way that we do this is take our given angle, minus pi over 15, and we will add to that a full rotation of 2 pi and find common denominator first. So this will be 30 pi divided by 15, which is 29 pi over 15. And that is the angle, as I illustrated above, starting on the positive x-axis and rotating in the positive direction all the way around to the same point that we ended with the negative pi over 15 angle, and that is the coterminal angle. And that is the conclusion of section 5.1 exercises.